Alright, now we want to grab a 3D model for our runner. What you can do is to go to the Unity Asset Store, so it's basically the marketplace for Unity, and type hyper casual character. So here you have a variety of options for the character, but they are mainly paid. I guess you can have some free versions here if you check free assets. These two packages are free, for instance. So you can choose one of these two, or what we are going to do now is to go to sketchfab.com and type hyper casual. Okay. Next, you want to tick the downloadable checkbox and select our hyper casual character, which is really nice here. Okay. So shout out to Marco Zaccaria for this package. Okay, nice. We can download the 3D model here by clicking here. All right, and select the FBX version. Download. All right. Once it's downloaded, you can see it here as a 3D object. So you can go back to Unity and create a new folder. And let's call it models. This will hold all of our models. Let's hit enter to open it. Let's go back to our folder and select our hyper casual character, drag it and drop it in the models folder. Perfect. We've now just imported our first character in Unity. But wait, it's not moving. And this is exactly what we're going to see in the next session. You'll learn how to animate this guy. So let's go. You can imagine that we won't animate our character by hand. Fortunately, there is a free website from Adobe that's called mixamo.com. So go to that website and see the amount of animations available to us. That's huge. Nice. We are going to use this website to animate our character now. So click upload character here, and we are going to drag and drop our character in this box. So let's open Unity, right click on the hyper casual character and click on show in Explorer. All right, perfect. Now let's go back to Mixamo, open our folder, drag and drop the character in the box. Now it should upload. While it's uploading the character, it's adding bones to it. This process is called rigging. And by animating the bones, we will be able to move our character or animate it as we wish. Okay, perfect. Once it's done, you should see your character animating like so. So let's hit next and next again. Perfect. First, we want to grab an idle animation. So let's write idle in the search box. And let's select one of these. So I think I'm gonna grab the breathing idle. All right. This one is pretty cool. Nice. Okay, so download it. And here in the format, select FBX for Unity. And keep all the other options as they are. So download. We also want to grab a running animation. So in the search box, again, type run. This should load some nice running animations. So let's select maybe this one. I don't know why they are not showing. Okay, Naruto. Oh, the other ones are showing. Okay, this one seems pretty cool. But the player is moving and it's bad for us because we want it to be static. We want to animate, we want to move the player by code later on. So tick the in place checkbox here. Okay, cool. Now it's not moving. Perfect. We can download this one again. Hit download. Perfect. Once we've downloaded our two animations, we are going to go back to Unity. Under our CrowdRunner folder, let's create a new folder called Animations. All right, perfect. Let's open it. Now we can drag our animations and drop them into that folder. Perfect. We now have our animations. Let's try one of them. So let's click on Animations here and hit play. Nice. You've just learned how to import animations into Unity. So in the next session, we are going to add all these cool animations to our runner and try and control it. So I'm gonna see you there. Welcome back. In this video, we are going to see how to animate our character. So first things first, select our hyper casual character, so the running version maybe, and drop it in the hierarchy. Okay, now you can see that it's huge. So let's scale it down. But first, let's create a new 3D object, capsule. Okay, this will give us the intended size. All right. So in the scene view, you can see that we can rotate weirdly here. I want to be able to rotate around the capsule. So for that, we need to click on the small box at the top right of the screen. Perfect. We just now turn into isometric view. We were in perspective view, if you want the terminology. All right. So now we can select our character in the hierarchy and diminish its size. So let's say 0.01, 0.01, and 0.01 on the z-axis too. Perfect. The size is now pretty much the size of a capsule, so we can delete our capsule. Nice. Now we want to add animations to our character. But first, I don't want to see the camera and the light icon here. So what you can do is in the hierarchy, click on the little eye here. All right, perfect. And you can also click on the hand to disable the possibility of moving them. All right, cool. Now, let's select our running character, right click on it and unpack the prefab because we are going to make our own prefab later. So basically the prefab is just an object in Unity that you can use and reuse multiple times, that you can instantiate at runtime. Okay, nice. Let's rename this guy to runner. It's more convenient as is. Okay, so the runner is made of two elements here, two main elements, let's say. The first one is the skinned mesh renderer. It's basically what allows us to see the player. So if you disable this component, we can't see the player anymore. The other game objects here are the bones that are used to animate the character. Nice. Let's add a component to our runner, and it's going to be an animator. This will help us animate our character. Perfect. So here we need to reference a controller. We don't have one yet, but let's create one. In the project window, right-click and create a new animator controller. Let's call it runner controller. Awesome. Then we can select our runner, drag the runner controller and drop it in the controller property. Perfect. We've done half of the work here, maybe more than half actually. Okay, let's open the runner controller here. Double click on it and we have this beautiful window that you can pan and move and zoom in and zoom out. So this is basically the place where you want to add all your animations and set up their logic. Okay. So I'm going to develop these two models here, select the first animation and the second one, and click Ctrl D. This will duplicate our animations and will help us read and write them if you want to edit them and so on. Okay. Now we want to add these two animations to our animator controller. So the easiest thing to do is to drag them and drop them into the animator. Perfect. So now you can spot a difference between the two animations here. One is gray and one is orange. Orange means that this is the layer state of the animator. So whenever you press play, it's going to play the breathing idle. So let's check now. Let's open our scene. Let's hit play. Okay, and in the game scene, of course, we can see it. But if you click on the scene window, you can see that the player is animating, but it stopped. And this is an issue. We want the animation to loop. So for that, let's exit the play mode, select the animator tab or window, double click on the breathing idle animation and tick the loop time checkbox. This will allow the breathing animation to loop. So let's hit play and go to the scene window again. And now we can see that the animation is looping. Perfect, this is exactly what we want. Then we can try again with the running animation. So to set the running animation as the default layer, we are going to right click on it and we're going to select set as layer default state. All right, you can see that it turned to orange. So let's hit play. And now we can see that the running, but I stopped promptly, sorry. The animation stopped, so we want it to loop. So double click on the running animation again. And in the inspector, check the loop time checkbox. All right, let's hit play again. Go to our scene tab, and we can see that the character is running. Perfect, but wait, we want to be able to move this guy now. So let's check how to do that in the next session. All right, guys, so in this lesson, we're going to try and move the character on the x-axis and on the z-axis. Okay, perfect. So first off, I want to add a plane to have a better vision of the character and so on. Then I want to make the runner a child of a parent of another game object. So what I'm going to do here, I'm going to right click on the runner and create an empty parent. I'm going to call this empty parent player. All right, perfect. Next, I want to create a new folder and call it prefabs. All right. So let's make our runner a prefab. That way we are going to be able to instantiate it at runtime whenever we collide with a gate. Okay, perfect. Then we want to create a new folder called scripts because we are gonna start scripting. Hooray! All right, let's open it. Let's create a new script called player controller. Okay, this is the script where we are gonna write all the logic to control our crowd. So let's grab it and drop it onto the player. Perfect. By the way, don't forget to save your project from time to time by pressing Ctrl S or by coming here, pressing File and Save. It's better, actually. Try and make some backups of your project too. Okay, so let's double click on the player controller script now. All right, perfect. Here is our player controller script. So the first thing we want to do here is to move our player along the z-axis in the forward direction. We want the player, that's the crowd, to move on the z-axis like so. So we want to change the z value of our position property. Okay, so let's do that. I'm going to write that in the update method. So the update method as written here is called once per frame. So if you are at 60 FPS, 60 frames per second, it's basically 60 times a second. Okay, so to move the player, I'm going to say transform to access the transform component dot position to access the position variable, which is a vector 3, plus equals, and I'm going to add something to that. So I'm going to add a vector 3 dot forward, which is the z-axis, times the time dot delta time. Time dot delta time represents the duration of a frame. So we are adding it here because we don't want the speed of the player to be dependent on the FPS of any device. Okay, perfect. So let's try this first. Let's hit play. And now we can see that our character is moving. Perfect. Now we want to be able to control this speed. So let's add a new variable in our script here. So let's create a new header for the settings. A header is basically just a label to organize your variables and properties. Then we add the serialize field attribute to be able to see our private variable in the inspector. So let's create a new float and let's call it move speed. All right. And here we want to multiply this vector by our move speed. This will allow us to control the speed of the player. So now if we hit play, and wait, let me quickly duck the game window right here because we don't need it for now. Okay, so now the player is not moving because the move speed is 0. To get the player moving, we need to increase this value. Now we can see that he's moving. If we want it to come back, we just need to make this value negative. All right, let's bring it back to 0 again. Perfect. Now our player is moving forward. So I'm just going to set a random value of 3 or maybe 1 for now. And now we want to be able to control our player on the x-axis, like so. So basically, we want to get the touch input of the player and use it to move our player from left to right or right to left. So let's do that. Here, let's create a new header for our control. Okay, perfect. So first off, I'm going to create a new serialize field, which will be a float for our control, or maybe let's call it slide speed. Okay, perfect. I'm going to grab this line and drop it into a new method called move forward. Okay, so let's drop it here. Perfect. And now I can call this method here in the update method. It helps keep the code clean. All right, let's create a new method called manage control. Sorry. All right, so let me quickly create this method. So private again, because we don't want other scripts to access this method. Manage control. Okay, cool. So first thing we want to do here is to detect whenever the player touches the screen. So if input.get mouse button down, and it's also available for the mouse. That's why it's mouse button down. You can use touch, but for now we are just going to use the input class. So whenever the player touches the screen, we want to save this position and also save the position of the player at this precise moment. So let's say clicked screen position equals input.mouse position. All right. So now I need to create this variable. So let's go right under control here and let's create a new private vector3. Oh yeah, vector3 clicked screen position. You could use a vector2 because the z component is 0 here because it's a screen position, but anyway. Then let's create another clicked player position equals transform.position. All right, same thing here. We want to create a new variable for this. So vector3 again, and this time we need the z value of this vector3. Okay. Then when the player is actually pressing the screen, input.get mouse button 0, we want to calculate the difference between the clicked position and the current position on the screen. That way we can use that to move the player on the x-axis. So I'm going to create a new float for that and call it x screen difference. This will be equals to our current position on the screen, so input.mouse position minus the position we clicked. All right, but we just need the x component of these vectors. So here we need to add .x. Okay, perfect. For this value to be responsive, we need to divide it by the width of the screen. So let's quickly do that. So we divide it equals by the screen.width. All right. And we also need to multiply it by our slide speed that we've created here. Okay, perfect. So let's do that quickly. So x screen difference multiplied by slide speed. Cool. Now that we have our now that we have the difference between the clicked position and the actual position on the screen, we can apply this to the player. So we can say transform.position equals the clicked player position, so the position we clicked at, plus vector3.right. This is the right vector, so 1, 0, 0 times the screen difference. That way we can move the player on the x-axis. So let's try it out. Let's give this a value of 1 and hit play. Okay, so now we need the actual game window to try. So I'm going to press move on the right, move on the left, and we can see that we can control the player. Perfect. But whenever I press here, you can see that the player stops. That's wrong. Let's fix that. So here, to do that, we are going to create a new vector3 called position. And we are going to initialize it to the position of the player. So transform.position. Then we want to say position.x. We only want to modify the x value of our position. So we're going to say position.x equals the clicked player position.x plus the difference. And then we can assign this position to our player. That way, we don't change the z value of our player. You see? Okay. Let's hit play again. So now the player is moving, and even if I'm moving him from right to left, he doesn't stop. So we just fixed our issue. Perfect. You don't want to miss the next lesson, because we are going to add a way to control our camera to follow the player, because now, as you can see, when I hit play, the camera is under the player, and even if I bring it up, I need to do something for it to follow the player. So let's do that. Alright guys, in this session we are going to see how to add a script or something to our camera to be able to follow the player. So first thing I want to do here is to grab the game window and dock it at the right of the screen. Okay, perfect. Nice. Now we are going to import a new package from Unity that will make things very easy for us. So let's click on Window, Package Manager. This brings the Package Manager window. All right, perfect. Just making it smaller. And here in Packages, you want to select Unity Registry. Perfect. Now we have a huge list of Unity packages that you can use for your projects. All right, I'm going to select Cinemachine here and click Install. Once it's done, you should see a Remove button here instead of the Install one. Okay, let's close this window. Here, notice that we have a new tab called Cinemachine. So press it and create a new virtual camera. Perfect. We can already see that we have some changes here applied to our game view. Let's just change the display and create a new one. I'm going to show you how to create a new one. I'm not using the simulator here again, just to make things simpler. I might use it in the future course or later on. All right, let's create a new resolution called maybe HD. All right, let's set it 180 by 1920. Okay, and press OK. Now you have your new resolution that you can select here. All right, cool. Then we want to configure our Cinemachine camera. So what I like to do first is create a new game object and call it camera stuff. So this is where we are going to put all of our camera elements and maybe also the directional light. So let's grab the Cinemachine element here, the camera, and the directional light. And let's put this game object at the top. Perfect. You can also create another one for the gameplay. Perfect. Let's grab the player and the plane and drop them here. Nice. Now we kinda have organized our project a little bit better. I like it. Okay. Perfect. Let's select our Cinemachine camera and check and see what we can do with it. So here we can add a follow. So this will be the object the camera will try to follow. we can also have another object that we want to look at. So here in our case, we want to follow the player, and we also want to look at the player. Nice. You can see the changes in real time in the game window here. All right, let's close this first. Now we are going to focus on the body part first. You can grab the Y component of the follow offset and dial it up. Perfect, so that we can have a better view of our player and later on the road. Nice. Then you have multiple values you can play with here that we won't go into detail in this session. Now we just want a basic setup of our camera. So now if I hit play, we can see that the camera is moving and trying to look at the player. Perfect. But one thing I notice here is that it also rotates with the player, which is something we don't want for this project. So in the binding mode, we're going to say world space. All right, perfect. We also don't want the camera to move on the x-axis. So we are just going to grab the little knob here and bring it all the way up to 20. That way the camera won't follow the player very much on the x-axis. Same thing for the Y and the Z damping. We want the camera to follow the player on the Z-axis. Next, let's develop our aim method. To prevent the camera from rotating, we can enable the window guides here. So if we hit play, we can see that it's trying to follow the player here. The little yellow dot is trying to follow the player. So we are going to increase the size of this window so that the camera always looks in front of itself. So here we can increase the dead zone height and the dead zone width. Now, when we move from right to left, it's perfect. Nice. So before hitting the play button again, check this save during play boolean. This allows the camera to save the settings during play mode. All right, perfect. Okay, I just had a small issue here with the screen X, but I set it back to 0.5. It was a little bit on the right. This is just to show you the amount of variables you can change in this Cinemachine component, and it gives pretty much you can have a variety of behaviors. Okay, cool. Now that the camera follows the player very well, we are going to see how to make a crowd system for our game. Perfect. Stay tuned. All right. In this lesson, we are going to see how to make the crowd system. So, first things first. We are going to take our runner here and duplicate it by pressing Ctrl D. Move it a little bit on the right. Create another one. Move it a little bit on the left maybe. And now check if they all move at the same time. So let's hit play. Okay. Perfect. When controlling our player, they do move at the same time indeed. Nice. Okay, I'm just gonna increase the slide speed here slightly, maybe from 1 to 3, so that we, okay, now it's better. Okay, perfect. Maybe even a little bit more, so 6. Nice. So now let's select these 3 and duplicate them a bunch of time. So just to see that there are many instances of the runners, we can select them and move them a little bit. All right, perfect. So now we have 12 runners. We are going to see how we can place them by code. Okay, so let's open Brave here. All right, perfect. So we are going to do arts with math, guys. Nice. I present you the Fermat spiral, and especially the Fermat spiral using the golden angle. We're going to try and set up an algorithm to place our runners in the same pattern. This pattern can be seen in nature, in the sunflower, or in the daisy, like here. All right, perfect. So let's try and do this. To do that, we need the radius of the spiral, which is going to be equals to c, so a random constant, multiplied by the square root of the current index of the runner. And here the angle is going to be equals to the current index of the runner multiplied by the golden ratio. So let's try and do that. Let's jump back to Unity. and create a new script in the scripts folder. Call it crowd system. Okay, cool. Now we are going to drag our crowd system and drop it onto the player. Nice. Let's open it. So just to try things out, here, let's place our runners on a line. It's just a test actually. So let's create a for loop. So we are going to loop through all our runners. So let's say transform.child count. This is the amount of children of this transform. So basically here the transform is the player and it has 12 children. Okay, nice. So the x value of the x position of our runner will be I, so the index, multiplied by 1. Again, it's just a test. So now we can say that transform.getChild, so we are getting the child I, so from 0 to 11, okay, dot position, but not position, dot local position, because we want them to move with the player, equals vector3.write, so the vector 1, 0, 0 times x. Okay, perfect. So let's jump back to Unity and hit play. Nice. Now we can see that our runners are on a line. Nice. We now know how to place our runners. So let's use the Fermat spiral. Okay. Let's create a new elements header. And let's add a new serialized field called golden angle, or just maybe angle. Okay. We can add another one called radius. All right, cool. And now let's create a new method that will help us place our runners. So let's make it private, void place runners. Sorry, runners. Okay. Now we want another method which will help us get the position of the runner. So it will return a vector3, so it will return the local position of the runner, get runner position, or let's say local position instead, and it will take an index as an argument, an integer, sorry. It will be the runner index. Okay, perfect. So how are we going to do that? So we know that the x position, the x local position of the runner will be something like, let's go back here, c, so a constant, multiplied by the square root of the index. So it's going to be c, so let's say the radius, times the square root. So we are going to use the mathf library. So sqrt is the square root of the index. And using some trigonometry lessons from college or earlier, we know that we can convert polar coordinates into Cartesian coordinates like we are doing right now. You don't need to remember that by heart. You just need to understand a little bit. And if you still have some questions, you can drop them in the comment section. So here we're going to say mathf.cosine of mathf.degree to radians. So it's just a conversion ratio here, times the index, times the angle that we want, because the angle is in degrees here and we want to convert it into radians because mathf.cosine uses radians. So let's grab this line, copy it and paste it. So now we want to modify the z local position of the runner. So here nothing changes, but here mathf.cosine, we want to use the sine of this angle. Okay, cool. Now we can return a new vector3 with our brand new made x and z values. Perfect. Now to place the runners, we are going to grab this loop, maybe remove it from here and paste it here. Nice. We can create a new vector3 called child local position and set it to get runner local position of index I. Okay, now we can grab this and paste it here. So now we are just assigning this position we've just made to our child, so to our runner. Then we can call the placeRunners method into the update method. Okay, let's jump back to Unity. So for the angle, we are going to use 137.508. So let's place it here. Okay, let's make sure it's a dot. And for the radius, for now, let's just say 1. I'm going to prevent the runners from going forward and hit play. Okay, let's see if that works. It seems that it's working. Perfect, cool, nice. Let's try and add more and more runners. So select all of them, Control D, Control D, Control D. Perfect. Okay, you can play a little bit with this. You can change the angle here and make some really nice patterns. Wonderful. All right. Cool. Let's set it back to the golden angle. And here I can reduce the radius, maybe 0.5 or 0.4. Yeah, it seems cool. Now we have a crowd. Okay, perfect. And using this algorithm allows us to prevent overlapping. Now you can see that no runner is on top of the other. So that's cool. Okay, perfect. Nice. Now, after doing that, we can add a crowd counter on top of the player to know how many runners we have in our group. Let's do that in the next lesson. Alright guys, in this lesson we are going to see how we can add a small crowd counter on top of the player, so on top of all the runners. Let's do it. So first things first, we first want to draw our bubble, let's say, that will contain the amount of runners. So for that, you can open your photo editor, but I prefer using a vector graphics editor. It's easier and more customizable. So I'm gonna get the bubble shape right here, and I'm gonna draw a bubble. All right, you can edit it to fit your needs. I like it to be somewhat like this. Okay, so let's convert this as a curve. Okay, cool. Then I can just grab these points and place them somewhat around the middle. Okay, perfect. And let's set it white. Using white sprites or images in Unity, is better because you will be able to change their color. Okay, cool. We've got our sprite. So now we can resize it or keep it as is. So I'm just going to keep it as is and export it. All right. So when exporting it, you want to create a new folder in the assets folder and maybe call it sprites. All right. That way our project is well organized. So let's double click on it to open it. And let's call this bubble. Perfect. Let's jump back to Unity. Nice. Now in our crowd runner folder, we should see a sprites folder. And here is our bubble. So for now, we can't drag and drop our bubble because it's counted as a texture. We need to change the texture type here to a sprite. All right, perfect. Now we can just apply the changes and it's now a sprite. We can drag it and drop it in the hierarchy. All right, here it is. Perfect. So now we want this bubble first to be smaller, but to follow the player wherever it goes. So for now, you can see that if I hit play, like if the player was moving and I hit play, the bubble is not following the player. So we have to do something for it to follow the player. The easiest thing to do is to grab the bubble and drop it as a child of the player. So now if I hit play, you can see that it's going with it, but I can't change the bubble's position because it's counted as a runner. If you remember well, in our crowd system script, let's open it quickly. We are setting the position of our children. So now the bubble is counted as a children of the crowd. So that's not good. To fix that, we are going to create here, and here, sorry, it was settings. It wasn't elements, but that's okay. It's just a header. It's just a label. So let's create a new header and call it elements. Okay, let's create a new serialized field, private. Let's say transform, and we are going to create a new parent for the runners. So let's say runners parent. Okay, cool. Then here, instead of saying transform.childCount, we're going to say runners parent.childCount, and you want to change this value everywhere you see transform. So here it's going to be runners parent.getChild again. And I think that's it. So let's try this out. So now we need to create our runner's parent. So let's right click on the player and create empty game object. This will be our runner's parent. Perfect. Now we only need to grab all of the runners and drop them into the runner's parent. Perfect. Now we need to specify our runner's parent to the crowd system. Here it is. Let's do it. Perfect. Now the bubble is following the player but is not counted as a runner. Nice. To be able to see how many runners we have, we need to add a small component to our bubble, which is called Text Mesh Pro. So right click on it, select 3D object and select Text Mesh Pro. If it's the first time you're using that component, you'll be prompted a small window like this one, and you just need to import the Text Mesh Pro essentials for it to work. All right, it should be quick. Perfect. Now we can see that we have a text right here. So first off, let's scale it down to the size of our bubble. So for the width, I'm going to say 2 for the width, and the height will be something like maybe 1. Okay, you can still press F to focus on the Text Mesh Pro. All right, let's drag it up. Perfect, maybe a little bit smaller. Okay, this is good. Let's bring it a little bit back on the Z axis for it to render before the bubble. Okay, now let's change our text. Let's say maybe 10 for our text for now, because we are going to control this value by code. Then you want to tick the auto size checkbox right here. That way the text will resize automatically with the size of our bounding box. For the minimum size of the text, let's say 1 or 5. 4 seems to be good. Perfect. We still can't see our text because it's white on a white background. So maybe let's color it black. And here we go. Cool. I like to align the text at the center. Okay, cool. It already seems pretty good now. What we can do now is change the font. So do we have some fonts here? We don't. So to change the font, I recommend using the DaFont website. So let's go there. Okay, perfect. Here we are in DaFont. To get some free fonts, you can select any category here. So maybe let's select cartoon. Let's show more options and tick the 100 free checkbox. Then submit. So now you have a variety of free fonts you can use for personal and commercial use. Let's use one of these. Maybe the first one, Milky Coffee. Okay, let's download it. Once you've downloaded it, you just need to create a new folder in the CrowdRunner folder, like so. Folder, and let's call it fonts. Okay, perfect. Now we can drag our Milky Coffee font and drop it in the fonts folder. But now we can't use it directly. We can't just drag and drop it here in the font asset. We need to create a font asset for Text Mesh Pro to work properly. So right click on the Milky Coffee font, select Create, Text Mesh Pro, Font Asset. So there is a shortcut for that, but yeah, you can just use it or not. Okay, cool. And now we have our signed distance field for our font. Okay, let's grab it. and see if I can drop it here. Perfect. Nice. We now have our font working properly. So maybe let's bring it a little bit below. Perfect. So now we want to create another script that will change the value of this text according to the amount of runners we have. So for that, select the bubble component, the bubble game object, sorry. So for that, in the script folder, let's create a new script. Okay, let's call it crowd counter. Nice. We can drag this script onto the player or onto the bubble directly. You're free to do it as you wish. So let's drop it onto the bubble for now and open it. Okay, perfect. So now we will need to add a library. This library is the TextMesh Pro library. That way we can use and change the value of our text. Okay, cool. Let's create a new header, call it elements, new serialized field again, and it's going to be a private field, TextMesh Pro. Let's call it counter, or maybe crowd counter text. Okay, perfect. So now if we go back to Unity, we can see that we can specify our crowd counter text in the inspector. So let's drag it and drop it. Let's rename this first, crowd counter text. Okay, perfect. Now we need to grab the data from this parent to know how many runners we have. So for that, we need a reference to it. So let's create another serialized field, which is going to be private. It's a transform, and let's call it runners parent. Cool. So now in the update method, so called 60 times per second or 30 depending on your FPS, we can say crowd counter text dot text to access the text variable of our TextMesh Pro will be equals to the runner's parent child count. But here we've got an error because this wants to have a string and this is an integer. So let's use a method called toString. And now we've just converted our integer to a string. Okay, let's go back to Unity. Let's drag and drop our runner's parent and hit play. Perfect. We now have the amount of runners in our crowd. So to try this out, let's remove one. Okay, perfect. Let's add 1, 2, 3, 4. Okay, let's select all of these and duplicate them a bunch of time. Perfect. It's working as intended. Nice. Now that we've got our crowd running, we need to add some ground for it to run on. And that will be the topic of the next lesson. Stay tuned.
Thank you for watching. Subscribe now and press the bell icon. Never miss any update.